Last night you were asked to complete on your own, right? With the smiley face? Letter C, D, and E. All right. So here we go. Letter C. Let's go over this. Letter C. What do you guys end up with? Jeremiah, what is the radians as a multiple pi for negative 60 bubbles?
I got 2 pi over 3.
For C? So Jeremiah said 2 pi divided by 3. True or false? False. What? What should we get? Drew said what? Negative pi over 3. Is that good? Yes. Check. Okay. Then you're at 270 now. Okay. So Ali, 270. What is that in radians as a multiple pi?
I got 3 pi over 2.
3 pi over 2. Is that okay? You got it? All right. Natalie said it's okay. Okay, we're on 104. Aaron, what did you end up with 104 degrees in radians, please? 26 pi divided by what? I'm sorry. 45. Someone confirm? Yes. If it's in radians, do I have to spell out radians? No. If I don't see a bubble, I'm just assuming it's radians, right? Okay. Yes. Can you what? Of course. All right. So, Drew, help me out with C. How did you get that answer?
I did what you told us to do.
Which was?
Negative 60 degrees of fraction.
Uh-huh.
And then do pi over 180 degrees.
Times, multiply, add, subtract.
Times
Okay.
pi over 180
Good.
degrees.
And then?
I took out the 0 in the bubble.
Okay.
And then I divided by...
So this is negative 6 pi then over what? 18?
Yeah.
Okay.
And then I divided by 6.
Divide by 6. So now it's negative pi on the top and then 3 on the bottom. Yes, Aaron.
So if negative 60 is 300.
Oh, good question. Leave her hair alone. Okay. Is negative 60 the same as 300 degrees? Raise your hand if you have that answer. Is negative 60 degrees the same as positive 300 degrees? Is it the same? What is the negative in trig? What's the negative in trig tell you to do? Yeah, aren't you traveling a different direction? Positive 300 is traveling what direction? Counter. Now, so are those the same? One's going clockwise, one's going counterclockwise. Would they be the same? They would not be the same. Now, the question is, are you going to be ending at the same place? Yes, then I agree with that part. But are they the same? The answer is no. Because we're going different direction. Okay? So it's like, think about this. If you're going to school, right? You have many routes to go into school. Would you agree? They are different, but would you still be at school? Yes. So hopefully that makes sense.
Cold.
It's cold. Mom, Dad, it's cold. Okay. Can I do D? D. How did you guys do D? Same thing? Okay. Take 270 bubbles over 1 times what, class? Times pi over 180. Okay. Can I cancel the zeros? Yeah. Okay. So that's really what? 27 pi divided by 18. Can I reduce some more? Yeah, they're both divisible by 9. So if I divide each by 9, I have 3 pi on the top and 2 pi on the bottom. So that is your D. Okay. Other questions, guys? Yes?
Does it have to be, like, on D, does it have to be 3 over 2 pi, or can you leave it like that?
Remember, pi can go where? 2 places. Pi can go on the numerator or on the side, on the outside, but never ever on the bottom. Okay. So the answer is yes, you can put pi on the side. Okay. So today, guys, we're going to do example 2 and example 3. Okay. Can you please, Sean, help me read the direction to example 2? Perfect. Example 1 was doing what? Degree to radians. So guess what? This is just the opposite. So here we go. Let's start with A. We have pi over 3 in radians class. We're going to multiply this to what? 180 over pi. 180 over pi. Okay? 180 bubbles over pi. Now, can I simplify? Yes, the pi and pi, right? Cancel. So now you have 180 degrees over 3. Now what? Is it perfectly? How many times perfectly? 60 perfectly. So 60 what? Degrees. What if I don't leave the bubble in there? Then it's radians, then it's wrong. Okay? Okay, B and C. I'm going to give you guys 6 minutes to try it out. Once you have an answer for both B and C, can you talk to your peeps? Talk to your team. So because I'm going to hand you this computer and you're going to teach us. Yeah. So please talk it out.
So you got over.
B and C. Yes, please complete B and C.
Okay, got it. I know I got it.
Yeah, and then you get 180 times 5. Oh, okay. Yeah, I didn't
Can you shuffle the cards?
Oh no, who's the unlucky person?
Okay, Chris, y'all's going to draw a card. Right, pick a card. Pick any card.
It's gonna be 3. Jack Swinger. It's Justine.
All right, Justine, here's your computer.
I want to write this shampoo. Can we do after?
Whatever Chris draws.
Wait, so what am I doing?
So you do letter B.
Oh,
Okay, shh, guys, Justine's going to talk it out, okay? So,
Okay.
what?
So, hold on. Pi. So then you multiply it by 180 over pi. 80 degrees over pi. So then the pi's cancel out, and then this can simplify to 90, and then you get negative 90.
Is that okay?
Yes.
Here's your card number 2.
Trevor.
Trevor.
Yeah.
Yeah.
He's not here.
Okay. Hunter. Ah. Okay. 10. And it's upside down. There you go. All right, he's gonna talk it out. So please.
All right, cool. So you have
Hello, class.
hello class. So you have 5 pi over 6, and then you want to multiply that out by 180 over pi. And the pi's there can cancel out, and leaving you and the 6 can cancel out actually too. So that's gonna leave you with 1 and 30. So you're dividing them both by 6, and so they end up over here with 5 times 30 over 1, which is just equal to 150 degrees.
Center okay?
Boom.
Okay, letter D. Letter D is a little bit different from the other 3 because what do you not see in letter D? A pi. So, Guys, is it okay to not have a pi in my radians? Great. Let me ask you this question. Pi radians equals how many degrees? 180. So pi radians equals 180 degrees. How much of a circle is that? Half a circle. Very good. Okay. So pi is half a circle. 180 is also half a circle. If I just say pi, what is the approximated value? 3.14. So would you agree that 3.14 radians, it's about 180 degrees? So if I say 3.14 radians, it's about 180 degrees. What is 2 pi radians? What is that in degrees? 360, right? Degrees. That's a full revolution. Can we agree? 3, but if you think about it, 2 times pi, isn't pi about 3.14? So is 2 pi, which is 2 times pi, is that slightly more than 6? So if I say 360 degrees, it's over 6 radians. Can we all agree with that? So 360 degrees is over 6 radians. Would that be okay to say? But right now in this letter D, I have 5 radians. Is that very small in my circle or quite big? Quite big, right? It's almost a full circle. Can we all agree with that? So it's okay to not have any pi in my radians. I don't have to have a pi. It's okay to be 5 radians or 2 radians or 15 radians, okay? But you need to know that, hey, if it's in radian, it's really big. Are we okay? So 5 radians, how do we convert that to any degrees? What do we always do? We take what? We take 5 times 180 degrees over pi. Now keep in mind that you're not going to have any calculator on these part of the exam, so make sure we can multiply basic math all on your own. So what's 5 times 180? 900, right? All over pi. Okay. Can I simplify that any further? No, because you don't have a calculator. But what am I missing? That's so important. Degrees, bubble. But bubble needs to be around the whole thing, because that's about 300 degrees, okay? Because again, pi is about 3.14. If I take 9 divided by 3-ish, it's around about a little bit less than 300. And it has to be the whole thing in bubble form. Any question there? Okay, so we have our last example of today, example 3. Okay, we're going to spend the remaining time, all next over 30 minutes, and just doing one last example. But before I do that, I do have homework to give you, so I don't forget. It's a worksheet. Okay, look at that. Yeah. 1, 2, and trace. Oh no. So let me pass out your homework first before I forget. 1, 2, 3, 4, and 5, and 6. Take one, pass it back. 1, 2, 3, 4, and 5. 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6. Okay, pass all the way back. Okay. So you guys all have a homework, right? If you don't, let me know. Okay, here we go.
Passing out math to everybody.
Example 3. Can you please help me, Mac, read the direction to example 3?
Example 3. Draw each angle in standard position. State what quadrant it's in, or if it is a quadrant angle. Find its reference angle, find its positive and one negative coterminal angle.
Perfect. So before we draw out the angle standard position, you did video notes last night. So August, can you tell me what the standard position is? What does it even mean? So look back at your vocab, August. Right, so it said the vertex has to be at the origin, and then the initial or the starting point must always be at the x-axis. Okay, so let's draw. Here we go. So here's my coordinate plane. Is that a positive 45 or negative 45? Positive. What direction? Counter. Very good. Where should I put my pen? Starting point. Well, the vertex at the origin. But where is my starting point? Positive what? X-axis. So remember, we're trying to make this angle. Why do I need that arrow? What is it telling? What is it stating? That is, I'm going counterclockwise, right? Because it's positive. What else do I need in drawing out an angle? The terminal psi. The terminal psi. Would you agree that's okay to have a terminal psi like that? So is the vertex at the origin? Yeah, right? So there you go. Letter A says we are supposed to state the quadrant. Lily, what quadrant is this in? Quad 1, do you guys agree? Okay, let's help with the quadrants. What quadrant is this? This right here. 1, yes or no? Good. Blue, what quadrant is this? 2. That means the next one is 3. That means the last one is 4. So those are the 4 different ones, okay? Letter B says what? We are supposed to, what? B says find its reference angle, okay? So, where is it? It's not shown on the screen. Can you see it? Oh, there it is. Okay. So, B, reference angle. Well, before you find it, what on earth, Shane, it's a reference angle, according to your definition.
A reference angle is an angle that is 90 degrees, greater than, less than, or equal to 90 degrees. That corresponds to an angle greater than less than.
I think he meant less than or equal to.
I meant less than or equal to, yeah.
Good. So letter B says, hey, find me the reference angle, okay? Class, is the 45 degrees already positive? Is it already less than or equal to 90? So what is your reference angle in this particular problem? 45 degrees. Okay. Letter C, you are to find one positive and one negative coterminal. So let's do positive first. Positive coterminal. Well, before we find positive coterminal, Summer, what on earth is the definition for coterminal angles? Good. 2 or more angles that have the same or what? Common what? Terminal psi, okay? So would you agree that this right here is my terminal psi? Yes, that's my terminal psi. That's where the angle ended. So I need to find a different angle, class, that will also end at the same spot, okay? So again, you start at the positive x-axis, which is here. Can I stop here? Can I stop here? Can I stop right there? Was that okay to stop in the green? So can I stop right there in the green? Is that a different angle? No, I can't stop right there, class. How do I get to the same terminal without stopping right there? How is that possible? No, I can't go the other way. I can look at a positive coterminal. I have to go full what? How big is that? So right now it's 360 degrees, right? But do I end right there? No, I have to keep on going. I have to keep on going to where? To infinity? To here, yes or no? Yeah. How big is that little piece? Another 45. Good. So currently, your positive coterminal is at 405 degrees. Okay? Next, I need now a negative coterminal. Class, negative coterminal means you go in which direction? Clockwise, all right? Start here. Can I stop here? In the bottom. How about here?
No.
How about keep on going, right? Here?
No.
Here?
There.
There. Okay. What is that? How big is that? Negative 315. Can we agree? So, okay, negative angle means I need a negative in the front, negative 315. Now, if I really wanted to, could I take negative 360 plus the original angle of 45? Would that also give me negative 315? Yes. Okay. So you can totally count. You don't have to do any addition or subtraction. You can just count, or you can just take the negative revolution plus the angle. All right, B. Same thing. First thing, it wants you to do what? Draw it out. So can you please draw it out? And then I'll hand you my laptop so you can draw it out on my laptop. Okay.
No, but isn't it on the water?
Oh yeah, because it's like a perfect. But then if it's negative, it's
So draw it out, guys. Do all of the parts. Draw it out. Answer letter A, answer letter B, answer letter C, positive, negative, coterminal.
Yeah, that's what I was saying. And then you said the other words. I'm like, okay, you know more than me. And then negative would be reference negative. Or no, you can go around twice.
You have all the parts answered here?
It's the one that less than.
It's going in negative. Would it just be 0?
What do you mean by 0?
What do you mean by finding negative?
What are you trying to find first?
Negative.
No, but what are you trying to find? What are you trying to find that's 0? You said negative, but what are you trying to find that's negative or 0?
I don't exactly.
What is your question? How about that?
How do you find the negative?
Huh?
How do you find the negative?
How do I find a negative? What do you mean? How do I find a negative? I don't know how to find a negative. Are you trying to answer one of the letters?
Yeah.
What letter? What is C asking?
Find it one positive and one negative coterminal.
Okay, so finding a positive coterminal, right? Is that okay? So did you find a positive coterminal, meaning that you go in counterclockwise? Would you agree? So if you go counterclockwise, how big is it?
270.
Perfect. How about a negative coterminal?
It was just going 90, then it was just straight downwards.
It is.
Or just-
So where do you start though? Where do you always have to start? Good. How do I get to that? Okay. So you're right. So far so good. But can I stop right there though?
Oh,
Yeah, you have to go full revolution. Okay. All right. Here we go. All right. All right, mister. Draw it out. Right there. All right, Jane's going to draw it out for us. Okay, shh. Look on the board, please. Is that right? Is that the right drawing? Yeah? Okay. Guys, you're always going to need this. Why is this important? This arrow. So I can know you're going the right direction. Good job. Oh, you can finish it up. Oh, yeah. All right, Jane, finish it up.
Okay.
Jane's going to finish all of it. You can touch the screen. It's not sensitive to. Okay, are those okay? Let's compare. Okay, so let's talk about the drawing. The drawing's okay, right? How about the quadrant? Did it end in quadrant 4? Did it end in quadrant 3? So according to your directions, if it doesn't fit in one of the quadrants, what do we call it? It's called a what? A quadrant. A quadrant what? Angle. Okay. How about the reference angle? Is it okay to have a positive 90 degrees reference angle? Yes. 270. It's the positive coterminal. You can count, couldn't you? If you don't want to count, you can take positive 360 degrees, add, what's your original angle? Negative 90. That will also be 270, okay? How about the negative angle? You can totally go a full revolution. Can we not agree? Okay? And then end it here. So what is that? Negative 360 and what? Plus? Negative 90. That will also equate to negative 450. Okay? All right. Any comments? The reference angle, it's always going to be positive, and it can only be up to what? 90 degrees. Since your original equation is already negative 90, and I can't have negative, that's as big as I'm going to have as a reference angle. Okay.
Is the angle they always give you going to be your reference angle?
No, ma'am, like this one. Okay, we have 4 more. Here we go. Summer wanted to know, the angle that they give you, is that always going to be the reference angle? So the answer is no, like this one, okay? It's okay. Here we go. Draw it out. Okay. Where should we have our pen? At where? At positive x-axis, right? Clockwise, going up or going downward? Up. Do I stop here? No? Do I stop here? No? Here? Before that. Okay, that's too much. Am I right? Okay. So here, before that. There. Is that a good one? Great. Letter A. All right, Connor, remind us, what is letter A again? Oh. Okay, so what quadrant? Okay, Jack, what quadrant is it a quadrant angle?
It's in quadrant 3.
Okay. Letter B. Okay. Letter B wanted us to find the what? Reference angle. So class, reference angle, meaning that it has to be positive and it has to be less than or equal to 90. And here's something that I want you to consider. You already have, so look on the projector, you already have this terminal side. Can you see it? Okay. The reference angle must always, the other side of the angle must always form with the x-axis. Can you see those red lines? So which side? This side is the reference angle in red? Or this side is the reference angle in green? Which one will give you a smaller, less than or equal to 90? The green or the red? The green. Okay, so that's how we find the reference angle always. The question is, how big is that green piece? How do we know to find that? What do we do? Luke? Say that one more time. You're right. You guys agree? The whole thing is 225 degrees, and then half of that circle on the top is 180. So your reference angle is at 45. Perfect. All right, letter C says you need to give me a positive coterminal and a negative coterminal. Okay. Positive coterminal. Right, I'm going to start again at the very beginning, which is here in my blue pen, right here. I'm going to go until I reach my terminal side. Can I stop right there in the blue? Is that my positive coterminal? No, because that's exactly the same as the original, right? So now what? Again. Can I stop right here? No, but that is how big? 360, okay? I need to keep going until I reach my terminal side. Can we agree? So how big is that? 360 plus what? Plus 225. Someone help me with the basic math. That is exactly 585 bubbles. All right, negative. Let me use a different color. Pink. Okay. Negative. Do I have to go very far Okay, let's start here still. See this pink mark? That's making the circle. Can I stop right there, class? Can I stop right there for my negative? The pink doesn't look very good. Black, I guess. We'll go black. Okay, there. Can I stop right there? Would that be okay to stop for negative coterminal? Yeah, I don't have to go a full revolution, class, because it's already different from the original. So how big is that? If I have to just count. How big is that? 135. Positive or negative answer? Negative, okay? Or you can take negative 360 bubbles plus 225, which equates to a negative 135. All right. We just practiced a bunch of the degrees, right? Guess what D is? Radians. I don't see a bubble, so it's in radians. We're asking the same thing, except now we are in radians, okay? So, are we ready? Okay. But before we start, I want to ask you guys a couple of questions, okay? Can someone tell me, if I give you pi over 2, what is that in degrees? 90 degrees. Can we all, is that okay? If I give you pi over 3, class, what is that in degrees? 60. Perfect. How about pi over 4, y'all? 45 degrees. How about pi over 3? I'm sorry, I already have pi over 3. I mean pi over 6. What is that in degrees? 30. Okay. So those are the basic angles, radiant conversion to n degrees, okay? So guess what I really want you to know? You need to memorize these, okay? It will come in handy. So now that we have that there, I wanted to ask you, 5 pi over 4, class, is that equivalent to 5 times pi over 4? Is that equivalent? Okay. Totally is. What on earth is pi over 4? How many degrees is that? 45 degrees. How many of those do I have? 5 of them. That's all 5 pi over 4 is. Okay? Oh. All right. That's what my triplets say. Mind blown, mommy. Okay. Draw it out. I would always start on the x-axis. Okay? I'm going to go 145 at a time. Okay. Would you agree that right there is 45 degrees or pi over 4? How many of these do I need? 5. So here we go. Let's count. 1, 2. What's that? 3, 4, and 5. So that's 5 pi over 4. Okay. You don't have to make a perfect circle. I'll take flower petals. Okay. So that's my drawing. Letter A. Chris C. What quadrant is that in, dear? Perfect. Okay. Letter B.
Isn't it just like this one?
Letter B. We're starting out with radians, class. If we're starting out with radians, all solutions must be in radians. You may not give me anything in degrees if we're starting out with radians, okay? Also must be, what am I writing? All solution must be in radians, okay? So if we're starting out with radians, all solutions must be in radians, okay? All right, letter B, class. I'm looking for what? Reference angle. Perfect. Keep in mind, reference angle is always going to form with which axis? X-axis. Here's a green piece, which is x-axis, okay? This is my terminal side. So class, can you tell me, should I pick this side in green? Or should I pick this side in red for my reference angle? Green. How big is that green? How many petals is that? How many petals is that in green? One petal. One petal in radians was what? I cannot write 45 degrees. I have to write pi over 4. All right. Letter C for cat. I'm looking for positive and also negative. Okay. Just like earlier, class, if I'm looking for positive, would you agree? I'm going to use a different marker here. I'm going to take this. Can I stop right here for my positive coterminal? Right there. No, I have to go full what? Circle. A full circle in radians is what? 2 pi. Beautiful. Plus, what's my original angle? Beautiful. Common denominator or no? No? Common denominator or no? I have to, don't I? What's my common denominator, class? 4. So this is going to be 8 pi over 4 plus 5 pi over 4, which equals out to how many radians? 13 pi over 4 radians. So that's my positive. Okay. Okay. Yes. 2 pi, good question. Class, where did the 2 pi come from? This right here. Yeah, remember, I'm looking for a positive coterminal. So, Brandon, I first have to go a full what? Revolution. That's 2 pi. And then I still have to add that piece. Wouldn't you agree? Yes. How about help me out with negative? What do you want me to write? Subtract what? Okay. We can take 5 pi over 4 minus 2 pi. Or can I write negative 2 pi plus 5 pi over 4? Would those be equivalent? Again, common denominator would be 8, right? So negative 8 pi over 4 plus 5 pi over 4 class is negative 3 pi over 4. Okay. Guys, can I just count if I don't feel like doing that? Could I count? Like here, if I put my pen here, see this black marking that I'm about to do? From here to here, it's 1 pi over 4, right guys? And from here to here is 2 pi over 4. And then from here to here is what? But I'm going clockwise, so what is that? Negative, okay? So you don't have to add or subtract. You can just draw it out and count. Okay, last 2 of today. All right, check these out. Which one's scarier? E or F? Which one's scary? F? Okay. We'll do F together. Then I'm going to let you guys do E on your own, and then we'll call somebody. All right. F, 21 pi divided by 6. 21 pi divided by 6. What should you do? Should I reduce? Oh, you should always. Okay. So, reduce. If I reduce, what would I get? 7 pi over 2. Oh boy. Isn't 7 pi over 2? It's like 7 times pi over 2? But what is pi over 2? 90 degrees. So when I draw it out, how many of those do I need? Just 7 times. So here we go. I'm going to start here, obviously. We're going to go count 1 pi over 2, right? And then, what's that? 2 pi over 2? 3 pi over 2? 4 pi over 2? 5 pi over 2? 6 pi over 2, and 7 pi over 2. Look at that. My circles don't have to be perfect. They can be petals as long as I have those arrows. Letter A. What is the answer called to our letter A? Quadrant angle is called, right? Yeah, it doesn't belong in any one particular quadrant, so we call it quadrant angle. Letter B, reference angle. Okay. Reference angle must always be what? Less than or equal to 90. Can it be negative? No. So again, remember it has to form with what? The x-axis. Here's your terminal side. So you really don't have a lot of choices. What's your reference angle, class? Just 90. You can pick the right or the left, but it's still 90. Okay. Next, we are looking for one positive, one negative. Okay. I'm going to count because sometimes counting is so much easier. Okay. I'm going to count positive first. Positive means I'm going which direction? Good. Can I start here? How many pi over 2 is that? 1. Luke? Oh, thank you. Okay, fix that. It has to be in radians. Thank you, Luke. Okay. So I just went 1 pi over 2, right, class? And from here to here is how many pi over 2? 2 pi over 2. And then my positive is at 3 pi over 2. Okay, so I'm teaching you both ways. Okay, adding and subtracting and just simple counting. How about negative coterminal, class? Can you count? Can I start here? Would that be okay to start? What direction are we going if I want a negative coterminal? Clockwise. Can I stop there? Can I stop there? Is that the terminal side? So can I stop there? Yes. What is that angle in radians? Negative pi over 2. Okay. Negative coterminal must have a negative in front. Okay, in your teams, can you please complete letter E? And then I'm going to give this to one of us to draw it out, answer all the parts. Okay. So talk it out, team. Can you leave your answer in degrees, class? No. Okay.
Which is basically
Yeah, if you're done, can you please talk to your team, make sure your answers match up? Or ask them, hey, how did you do this? Or cheat somebody.
I like it. So it's going to be just so none of these create
What's your drawing? 60.
Sorry, it's gonna drop me if I don't click that.
Can I do this and add the pi over 2 and the pi over 6?
Let me see. So the positive is all the way here, right?
Look at all this.
Yes, I totally take it.
Okay, so it'd be 5 pi over 3?
Right.
Okay, thank you.
Okay, here we go. Look, draw a card. Draw any card.
Jacqueline. I picked your card.
Okay, Jacqueline, here is your. Oh! It went sideways. Woo! All right, Jacqueline, talk it out.
Wait, oh, right here, right?
Yep.
Okay. I think I clicked something. Okay,
So draw it out first.
so here, go down. That, right?
Is that right? Yeah. Okay, good. Letter A.
Oh, I have to do everything?
Sure.
Okay, so it's in quadrant 4. And then the reference angle is pi over 3.
You guys agree? Good.
And then for positive, I got 5 pi over 3.
Which is right, Jacqueline, but how did you get it?
Okay, do I have space?
So right equals, there you go. Uh-huh.
I'll just do it there.
Yes.
So I did pi plus pi over 2 plus pi over 6.
Yeah.
And then I got 10 pi over 6, which can be reduced to 5 pi over 3.
Yes, I totally agree with that. Very good. Natalie. The reference and can never ever be negative. Okay, move up. Use your hand. Jacqueline, there you go.
And then for negative, I did negative pi over 3 plus negative 2 pi.
Very good.
And I simplified that to negative pi over 3 plus negative 6 pi over 3. And I got negative 7 pi over 3.
Beautiful. You guys agree? Okay, so there's a request for counting. Can I count? Okay, yes, I can count. Sometimes. Thank you. Okay, so reference angle. Here we go. Positive reference angle. Wait, here's how you count, guys, just quickly. Would you agree that this is already pi over 3? Right? So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. Adios. Hasta mañana.